Pavement, Protection, and Public Lands in the United States by Roucka, Environmental Studies and Geography GIS student at the University of St. Thomas. In this presentation, I will give background information on ecological integrity and the impact of pavement on ecosystems in the U.S. I will also define the Gap Analysis Program PAD 1 and 2 protected areas, and will help to explain the relationship between pavement and protected areas through scholarly research. Finally, I will use ArcGIS to convey the relationship between pavement and protection. Geographer and conservation biologist David Theobald wrote an article about ecological integrity and how human modification impacts it. According to Theobald, human modification includes data on land use, land cover, and the presence, use, and distance from roads. In terms of effective conservation, Theobald combines landscape integrity scores based on how well the ecosystem supports a community of organisms and the protection status. The protection status is based on the Gap Analysis Project results, which rank U.S. public lands on a scale of 1 to 4. Gap 1 and 2 are protected areas, and Gap 3 and 4 are not. Gap 3 includes fishing and hunting, and Gap 4 includes mining and extraction. Pavement, an impervious surface, plays a big role in human modification of ecosystems. Pavement prevents the infiltration of water into soil, and runoff can cause erosion, which can then result in loss of habitat. According to Chester Arnold and C. James Gibbons of the American Planning Association, development overall severely affects the environment and ecosystem services. As for the impact of roads more specifically on ecosystems, roads are engineered by humans for human purposes. Planners and developers often do not take into account the negative ecosystem impacts such as habitat fragmentation, which can cause the butterfly effect among species. According to Kurt Ritters of the Ecological Society of America, roads disrupt the movement of wildlife across the landscape and have the power to change water drainage patterns, introduce non-native species, and increase noise levels. Roads also have the power to change microclimates and chemical environments, as well as to create new patterns of communication within ecosystems. Road network expansion and development will pose a recurring threat to ecosystems. The Protected Areas Database of the U.S. is the official inventory of protected areas, and it contains over 715 million acres of land. The Gap Analysis Program provides data and tools to address environmental concerns such as conservation, renewable energy development, climate change resilience, and infrastructure investment. From a historical perspective, American protected areas, specifically national parks, had the lowest number of housing units within 50 kilometers. However, in 2000, the number dramatically increased, creating more development and thus pavement in and near protected areas. This development creates a disconnect from other wilderness areas, making it difficult to protect threatened plant and animal species. Without corridors of protected land between wilderness areas, species cannot effectively move from area to area. In terms of the scale used to convey the relationship between pavement and protection, a watershed scale approach is most effective because this approach prevents relying on site-level data. Restoration should start with an understanding of the ecosystem processes operating in a watershed because watersheds contain data on water, soil, and other variables from more than one source. Before I began the GIS portion of the project, I came up with some research questions to guide my research. Is the presence of pavement associated with highly modified environments? And is protection effective in reducing the negative environmental impacts of pavement? This map from EnviroAtlas conveys percent impervious in the US. Black shows a high percentage of impervious surfaces and white a lower percentage. As you can see, most dark areas are clustered in and around urban areas. This USGS map conveys percent gap status 1 through 4. Green conveys percent 1 and 2 are protected, and red conveys unprotected. Yellow and orange convey land that is somewhere in between. Most of the protected areas are concentrated in the west, where a majority of the national parks are located. This scatter plot conveys percent gap status 1 and 2 versus percent impervious. Most protected lands, conveyed in green, only have a small percentage of impervious surfaces, if any at all. These areas show up in the top left corner of the scatter plot. Most unprotected areas, conveyed in red, fall in the impervious category towards the bottom center of the scatter plot. As you can see, there are some exceptions, such as this point highlighted in blue and circled. This area is in Chicago, specifically the Lower DuPage River Watershed District. This area is protected, but paved. In the top left corner of the scatter plot, the areas conveyed are protected and not paved. I highlighted these areas on the map, and most of them are in the western United States. I zoomed in on a few of these areas in Idaho, Minnesota, and California. Idaho and California are mountainous, Idaho more green and California more bare. The Minnesota base map snapshot is near the boundary waters, so it is heavily forested. Here, I zoomed in on unprotected, but not very paved areas. As conveyed on the map, much of the country is unprotected and pervious, with the exception of portions of the West. I took base map snapshots of some unprotected but pervious areas in Illinois, Maine, and Nevada. The area in Illinois appears to be rural agricultural land, and the area in Maine is along the coast. Overall, percent gap status 1 and 2 protected areas correlates closely with lack of pavement. Non-protected areas are associated with pavement and other impervious surfaces. There are local exceptions, for example, the urban watershed in Chicago that is protected. But, generally, the presence of pavement is associated with highly modified urban and suburban environments. Protection is effective in reducing the negative environmental impacts of pavement, and the scatter plot data supports this. Where there is a lack of pavement, there are reduced negative environmental impacts. Without pavement, it is easier for water to infiltrate into soil, runoff and erosion are minimized, and habitat fragmentation is less of a threat. Similar research was done in Brazil. The Brazilian government had plans to pave roads in Amazonia, which would double the area of rainforest accessible by roads. This new development would cause logging and deforestation. Aside from physical environmental impacts like deforestation, there are human health impacts associated with roads and development. Car emissions are the main cause of air pollution, and air pollution can affect the respiratory, cardiovascular, nervous, urinary, and digestive systems. Pavement can also impact human social and mental health. Car accidents can result in severe injuries or death, and roads and automobile dependency are associated with community fragmentation and social inequality. The highway that went through the Rondo neighborhood in St. Paul is a good example of this. Thank you for listening.